So we'll go ahead and get underway with solar roofing best practices. Hello, my name's Jeff Spies, and over the next hour, we're going to discuss installing PV on low slope roofs. Now, there's a misnomer that's often applied to these types of roofs. They get frequently referred to as quote unquote flat roofs. And as I like to say, you can have a flat roof. First and foremost, there's no roof that's really purely, truly horizontal, because it wouldn't drain water and it would fail quickly because the water wouldn't drain off of it fast enough. There's always going to be some degree of slope to help water drain off the roof. But a flat roof is certainly desirable, but that flat roof would typically be pitched up a few degrees or more in order to, again, facilitate water drainage. So the discussion that we're going to be focused on here is our low slope mount pictured on the left-hand side of the image, installed on a low slope PV system, which you can see on the right-hand side of the image. A quick mount PV manufactures a broad range of flashed attachments for just about every roof type, with the exception of metal panel roofs like standing seam or a corrugated through fastened metal panel roof. For those products, we typically, or for those applications, we refer folks to our good friends at S5, who have a broad range of attachments for both standing seam and through fastened metal panel roofs. That said, we offer solutions for asphalt shingle roofs, tile shake, slate metal shingle, and low slope roofs. Our latest products in the tile realm include our tile replacement mount, where we have a form-fitting flashing that fits about 80 to 90% of the concrete tile roofs that are found commonly used. Both in we have S-tile, W-shaped tile, and flat tile solutions that work really well. We've also extended that concept of a replacement form-fitting metal flashing to tile hooks, like our quick hook pictured on screen, again offering it in flat, S-shape, and W-shaped tiles. We do have conduit penetration flashings for tile roofs, as well as conduit mounts. And our latest product in the asphalt shingle realm includes our L-mount, which is a very low-cost flashing with our elevated water seal. It uses the flute that you can see pictured in the line drawing on the right, with a custom L foot that's included that fits over the flute with an elevated water seal. So this helps offer a very competitive price that would be suitable in many markets where having the more modest elevation off the roof surface is sufficient. Our classic conduit mount has been improved with rounded corners and nice alignment guide notches, and our more recent product, the Q-Box, allows you to take your PV cables in through the weather-tight fittings pictured here. You would add those yourself, and into a elevated water seal to bring those conduit, the cables into a conduit that goes into the roof. We have also upgraded our popular E-mount with the rounded corners and alignment guide notches, and our quick rack rail-free system for asphalt shingle roofs is easily found on our website, where we have a lot of training materials. Those folks that are using rail-free products really need a solution to attach maximizers or microinverters to the back of the panel, and fortunately we have a listed UL 2703 universal accessory frame bracket that permits that to be done easily. It also speeds up installation by helping you put that component on the ground, transport it up to the roof with all the PV cables already managed, as you see in the image. You can get our low slope mount or any of our products at our website by clicking the green free sample button. And I do want to point out that we have, over the course of the past 6 months, launched a new podcast titled Solar Roof Talk, hosted by myself and my coworker Sue Stark, where we address a number of topics that would be of general interest to the rooftop solar installation community. Our most recent episode that you see at the bottom there addresses the new relaxed fire setbacks and pathways. So if you're interested in learning more, just Google the search term Solar Roof Talk and you can learn more. Our mobile training center is crisscrossing the country over the past 9 months, and if you're interested in having it come to your place of business to get a little on-site training, just contact our sales force to learn more. My name is Jeff Spies. I'm the Senior Director of Policy for Quick Mount PV. I also serve as Secretary for the industry certification organization NABCEP, the North American Board of Certified Energy Practitioners. I do serve as the on the board of the California Solar Industry Association, where I chair the Committee on Codes and Standards, and I am a member of the UL 2703 Standard Technical Panel, which is the standard that pertains to rack-mounted PV systems, where I lead the task group on bonding and grounding, which is always a robust discussion. My degree is mechanical engineering. For 30 years, I've been training folks, done a lot of training and writing for industry trade publications and organizing major training activities. But really, my hobby is the same as my career. I really, truly enjoy solar photovoltaic technology. I find it quite magical overall. My own home system was profiled a few years back in an issue of Solar Pro magazine, where I was on the inside back cover showing off my PV system, which we had to do some innovative things from at that time from a roofing perspective, and the inverter was one of the first generation of a inverter that could operate when the grid was down to provide 12 amps of power to a switched outlet in my dining room. But most thing I've been most excited about the past couple of years is I've been working on a documentary film which recently debuted titled Solar Roots, that tells the story of the start of the PV industry, where we interviewed over 50 people that really were the who's who of the pioneers of the early days of the industry, including Richard Perez, founder of Home Power Magazine, who passed away at his homestead a year ago in Oregon. But we cover the early stages of the development of PV in the 1800s, when the scientific discoveries occurred, through the development of the silicon solar cell in the 1950s, its rapid deployment in the space program, focusing on that colorful group of characters that helped make PV into an industry in the home power market. And again, over 50 people we interviewed, and it'll be shown at industry events over the next year. Now let's talk a little bit about the basic premise. Keep in mind that my buddy Brian, pictured here, has modules that are now 35 years old. Let me think, actually 36, maybe 37 with the change of the year. These modules were originally installed in 1981, reinstalled by Brian when he got them for his homestead about a year and a half later in 82, and they've been operating continuously during that time and still producing quite well, and over 80% of their original power output. So the fact is that I know many people like Brian who have modules that have lasted well over 30 years. Will your flashed roof mounts and roof last this long? And for most people, the answer is no. Now, I do want to emphasize that there are lower cost ways of waterproofing, but in the world of low slope roofing, that's very risky, because the fact is we don't have the slope to help us drain water efficiently. There's a greater amount of risk, and inexpensive flash mounts just don't really save the kind of money in the long run, particularly for the customer. It's not worth the risk. I just want to point out, in the inaugural issue of the industry's top trade publication, Solar Pro magazine, this is back in 2008 when they launched their publication, they reported that 80% of lawsuits in the construction industry occur because of water intrusion. Now, that's predominantly from roof leaks. So this is the reason why one must take this issue very seriously. Got to realize that removing and reinstalling a PV array to fix the roof is expensive. It used to be somewhere between 20 to 40% of the cost of a brand new system, although with system price declining, maintenance to remove and reinstall doesn't decline. It's not a function of having a lower cost module to bring your price down. So this is a big consideration. It actually costs more to fix the roof or replace the remove and reinstall the array than it does to replace the inverter. And during that process, particularly as the array ages, you'll end up with higher costs because of the damage to the racking system, grounding, wiring. Wood rot and mold can drive that price higher, and something to take seriously. Now, Quick Mounts, a leader in the industry. We are the largest manufacturer of residential flash roof mounts for PV installation, 25 plus years of experience in the metal construction, solar installation industry. We are dedicated to quality, and we have code compliant products to assure waterproof solar installations over the life of the PV system and a new roof. Very much committed also to the future of solar power and sustainability. So I want to again encourage everybody here to ask questions. And I'm just going to launch one more poll here really quickly just to get a better sense for how long you folks have been operating in the solar industry. That'll give me a better appreciation for who we're talking to. We already recognize that most folks have the desire to install on both residential and in commercial roofs. Let's see how long you folks have been in the industry. We've got most here that have been in more than 3 years, a handful that are less than a year, and it appears that the bulk of our audience seems to be relatively experienced, which is great. Obviously, that should help get some more sophisticated questions over the course of today's webinar. And I'll go ahead and close the poll. So about half of you have been in the industry for quite some time, and just a smaller number are new to the industry. So we'll go ahead and talk about mounting PV on a low slope roof. And this is our product, the low slope mount. It's a very structurally robust standoff, a base and a post that gets bolted either into the rafter or into some kind of a deck, often into a metal deck, and then you would flash it either with a conventional aluminum cone flashing or a membrane flashing dictated by the type of roof that might be used. Now, there's precious little research available, unfortunately, to give us a sense for what life expectancy is of the roofs that are installed today. That said, there was an interesting study done in 1997. At that time, and keep in mind, technology has progressed over the past 20 years. But at that time, a metal panel roof had an average life of 25 years, coal tar pitch built up roof, 22 years, asphalt built up roof, 16 years, EPDM 14, TPO 12, foam roofs 11. Now that's relatively modest life. That said, over the past 20 years, we've seen the roofing industry evolve with the objective to manufacture membranes that have the capability of lasting more than 30 years. That's great for PV because if you install a PV system now on a new single ply membrane roof that has the capability of lasting 30 years, you now have some confidence that when done correctly, your PV attachment to the roof and the waterproofing should be able to last the life of the new roof and the new PV array. Now, that said, the membranes that have been manufactured in recent years with the intention of being used with PV are usually extra thick. It used to be you'd get roof membranes that would be 30 mil or so thick, but they've increased in thickness upwards of 100 mil. So that really has helped extend the life of the roof. It does require diligent maintenance. Twice a year is the norm in the world of low slope roofing, particularly for commercial low slope roofs, because the cost implications are so significant. So this is a typical example of a residential low slope foam roof, which is very common in many parts of the warmer part of the U.S., the southern U.S. Here in Arizona, low slope foam roofs are very common. And this particular low slope roof has a tile steep slope roof that transitions into a foam low slope roof section. You'll notice that the racking system here, which is installed on standoffs, has had the roofer come back in and foam over where the standoff is to give it a nice elevated flashed mount, and then it's mounted to a conventional rail-based system. So this is a really, I think, great approach, if for no other reason that as the time goes by and the maintenance of the roof gets done, this low slope installation has very good access and visibility for the homeowner and or the roofer most times to visually verify that there aren't any problems developing. And when it does come time to service the roof, one can easily get in here and apply a new coating. This is the reason that low slope foam roofs can work so well when maintained, is that you can recoat it after a matter of 5 years, and that will buy you additional life. So the life that we saw 20 years ago, through proper maintenance and better materials, better coatings, we are finding that the life of the roof under the PV array can extend tremendously longer than what existed 20 years ago. Now, as I stated earlier, the term flat roof is a misleading term because flatness has nothing to do with what angle it's pitched up from the horizon. That said, low slope roof terminology tends to be the dominant approach to describing roofs that are less than a 212 pitch. Now, the minimum allowable pitch by the International Building Code is a 1/4 inch rise for every 12 inches of run, and that is a very low slope roof. In fairness, few roofers really are comfortable with pitches that low because they don't drain water quickly, which is the key objective in the low slope roof realm, is to get that water off the roof, dry it out completely, ideally within 12 to 24 hours. The drainage pathways that are provided, and this is a very simplistic diagram showing the basic concept in a low slope roof, is that you have defined drainage pathways that either lead to some type of a scupper or a drain in the low slope roof. Here we got a scupper, it's called, just a hole through the parapet wall. Typically you'll have some type of a device mounted on the external part of the wall that will harmlessly drain water either into a gutter or at least away from the base of the structure to prevent erosion. The key to realize again is that if you don't get that water off the roof quickly, you're going to end up with biological growth, which will lead to leaks. Now, this roof that you see here is an interesting example of a traditional large commercial low slope roof. It happens to be the, I think it was the Hilton Conference Center that we had a conference for the International Roofing Expo back in 2012. And the picture that you see taken there was 12 hours after a big rainstorm, and you can still see the water that's remaining in those drainage pathways. Kind of looks like creeks that feed into rivers that feed to the drains that are pictured in the left-hand side of that roof. But notice, if you count them, there's probably a good dozen distinct drainage pathways as you go from the far side of that roof at the top of the image all the way to the bottom of the roof here at the bottom of the image. And in theory, those drainage pathways should not be blocked after PV is installed. Now, these drains pictured in the lower right here, there's 2 drains there. Notice that generous black stain. You can see where that water sat. Again, this roof was dry within 24 hours. But the pictures that I took occurred at the 12-hour mark. And that drain area, of course, has a big reinforcing patch because they know water collects around drains. It should be the low spot in this roof. Although that black biological growth extends to the left off that patch. So that's a section of roof that will deteriorate prematurely. It is common practice to install patches like this one that you see here. This roof was littered with small patches. The logic being that you have a roofer every 6 months walk around the roof. Anything that looks suspect gets one of those patches. And I would say that it was hard for me to really get a good tally. But again, there were dozens of these patches scattered across the surface of this low slope roof, demonstrating that it had been installed for a matter of years. And those patches really do keep the roof alive over the long term. Now, we do have a checklist here that talks about all the things that one should look at when you're trying to evaluate a PV system for a low slope roof. Looking at the original roofer of record really has tremendous value in the low slope realm because these roofs inherently require more maintenance. And as a result, having the relationship with that original roofer can pay big benefits to the system owner, the building owner, the PV installer even. Knowing what kind of roofing manufacturer or materials are used, who the manufacturer was, what kind of warranties, are they contractor or manufacturer? I feel in the long run, a manufacturer-backed warranty is certainly of value in many roofs. Material warranties are great. That's what most people have. Workmanship warranties are better because usually the cost of roofing is more in labor than it is in material. Obviously, identifying the age and remaining life of the roof. Now, that said, the question often is asked, hey, how old can a roof be before you might not want to install PV? And that's a very subjective question or subjective answer, so to speak. There's many variables. That said, when I talk with roofers who I respect, they tend to feel that if a roof is more than 5 to 7 years old, maybe more toward the 5-year mark in the low slope roof realm, that replacing the roof or the membrane before installing a PV array has tremendous long-term cost benefits for the customer. Obviously, evaluating the structure and determining if repair might be necessary. Is there any evidence of existing leaks? What kind of decking do we have? Plywood, oriented strand board, concrete decking, corrugated metal decking, what type of corrugated, what thickness? All of these have some impact on the choice of your roof attachments or your mounting method. And finally, your rafter purlin size and spacing. Certainly, you're going to look at your engineering design layout of your racking system and the proper mounting and flashing. Now, this is the core of the discussion. In recent years, over the past 8 years, we've seen a rapid evolution towards using ballasted racking systems pictured on the top. These are, the term ballast, of course, ballast is a fancy term for weights. More often than not, those ballast blocks are concrete blocks, and they hold the PV system down to the roof itself. Whereas a penetration-based, mechanically attached racking system like our low slope mount, the concept is you bolt it to the roof deck, to the structure below, and then you have a more of a ground mount style racking system. The benefits here I'll mention in a minute, but that's the basic premise or comparison of a ballasted system held down by weights compared and contrasted to a mechanically attached racking system. So ballasted racking we'll talk about first, and I will again encourage anybody that has questions, just type them into the question box. But ballasted mounting systems, because now you have weights holding the metal, usually racking system, sometimes plastic racking system, down to the roof membrane. Well, the first thing to be aware of is that you would benefit from or mandatorily be required to provide what's called a sacrificial slip sheet. In the case of a low slope membrane, like you see on this roof here, it looks like it's probably a TPO material. That's one of the most common, if not the most common membranes used today. It's white to give you that good low, it will absorb less heat than a darker roof membrane. But this racking system will move around on that roof over time. Ballasted racking, since it's not firmly mechanically attached, will, just by nature of expansion and contraction, that ballast tray will slip on the roof membrane over time, back and forth, and that eventually will wear through the membrane, which is why the single ply membrane manufacturers now, usually for PV systems, mandate that you have a sacrificial slip sheet installed under the ballast pad. You also have the concern over ponding rainwater. Remember that image I showed of that large green low slope roof in Orlando, Florida with that rain after the rainstorm? Well, there's dozens of drainage pathways in that roof, and you can see if you have all these ballast blocks that are mounted in trays on that roof, you could very well block the drainage pathway. So that's a risk that exists on many, if not most, ballasted racking systems installed on low slope roofs. You also have the added challenge of the ballast tray, that concrete block that sits in a tray, compressing the foam insulation under the membrane, maybe just even compressing the membrane, leading to a water collection area that can facilitate advanced deterioration through the biological growth. Now realize, as you can see from this image, that locating a leak and repairing it is difficult because much of the roof is either difficult or impossible to access, but also difficult and impossible to see. So sometimes those leak areas, particularly the ones under the ballast trays, won't be visible because they're covered with the ballast tray. Now, dismantling and reassembling the system requires not only a qualified solar contractor to do that work, but you need a qualified roofer to perform the actual service and diagnostic leak detection of a roof. Now, leak detection on certain roofs, like built-up roofs, can be really tricky. There's actually some fairly sophisticated diagnostic instruments that will help you pinpoint leaks in low-slope roofs, and sometimes they're pinhole leaks, so they can be tricky to find. These diagnostic machines that sell, they're quite expensive, but they will sometimes detect the leaks through continuity. So if you have water leaking through the membrane, it will have an electrical current that will go through that. And either way, just be aware that it's a real tricky proposition when a PV system covers much, if not most, of the low slope roof to figure out where the heck those leaks might be located. Obviously, as the system ages, as mentioned previously, you're going to get usually racking damage, module damage in some cases, certainly wire damage. What I discovered when I took apart my first 13-year-old PV system is the insulation on the cabling that was under the arrays kind of took a set and no longer had that nice elastic being able to bend back and forth like the PV modules come with the wires right out of the box. Over the years, the PV cables will take a set where they will no longer be elastic. They start to become the stiffness of a piece of cardboard. And so when you take that module apart, it's best whenever possible to minimize rebending those PV cables. Mark where they came from, try to put the cables back into the same orientation, but there's a likelihood that you're going to crack insulation, setting up the potential for a arcing fault problem over time. Now, one of the interesting things about ballasted racking systems is you still need some penetrations. And the reason is that the PV system moves around on the roof. You don't want your conduit to be your only point of physical connection. You have to realize that ballasted racking systems have to be anchored to withstand wind loading, seismic loading, vibrational loading, just the nature of an air handling system with its compressors and motors and fans that are causing vibration on the roof. If you don't anchor that PV system, it can literally, over the years, walk downhill. And finally, the inevitable expansion contraction caused by the sun heating up the PV module, the racking system. It's metal, it expands and contracts, oftentimes at a different rate than the roof that it's mounted to. And that small but important movement back and forth can again cause a degradation of the membrane on a low slope ballasted racking system. So mechanically attached, on the other hand, the real benefits of it is strong, robust mounting. Realize that it's highly resistant, as one can imagine, to wind loading. You're physically attaching with bolts the PV system to the structure under the roof membrane. Obviously, seismic concerns are mitigated by the fact that you got that mechanical attachment. Any vibration load isn't going to cause any movement. And a big advantage, particularly in lighter weight roofs in commercial realm, is that it's less weight. You don't have big ballast blocks weighing the whole system down. You don't have to worry about compressing the insulation or the membrane under the ballast tray. Highly reliable waterproofing. When you have the flashings installed by a qualified professional, realize that there's in a typical single ply membrane roof, you have hundreds, thousands of feet, maybe miles of welded seams of one roll to the next. And the flashings that are used to waterproof the low slope mounts are welded in precisely the same manner as the thousands of feet of welded seams on a typical large low slope roof. So the waterproofing is highly reliable when done by a qualified roofing professional. The other thing that's really convenient is it allows use of a standard racking system that might be used in a ground mounted PV system. You can actually use multiple row arrays like the image pictured, which now gives you access, visibility under the PV array so you can perform service over time, extending the life of your roof, driving down your cost of installation. So our low slope mount is available as a standard product in 3 basic heights, 7, 9, and 12 inches, although we have custom heights up to 18 inches. So check with our sales group if you have a requirement for a height other than the 3 standard sizes that we typically sell. It is the strongest mechanically attached production solar mount that's used out there with an all aluminum base and post that has a 50-year life, adheres to roofing standards and best practices, and available in the standard mill finish, which is the vast majority of what we sell. But for those folks that might be in a really harsh environment, like the coastal sea spray kind of applications, we do offer clear anodized and bronze anodized. It sometimes is actually chosen also for aesthetics, although the interesting thing about low slope roofs is it's very rare that you can see the PV array on a low slope roof. So in this case, the finish is going to be predominantly a function of corrosion resistance. Our buttressed Q-base is offering unprecedented mounting strength, and we actually have done a test where we bolt that base to a steel plate, half-inch thick steel plate, and then we put a side load on it. And and showing the mode of failure, sometimes the post will compress and bend. Sometimes the base will crack, but you can see for the 7-inch that your side load or the shear load is still very significant, upwards of 1,100 plus pounds average. This allows us, by having such a strong base, to use really tall posts to clear thicker insulation on roofs that are really highly insulated, up to 8-inch tall cone flashings on roofs that have several inches of installation. And depending on whether you're mounting it into a rafter or to a metal deck, you can use 2 bolts or 4 bolts. The roofing types that this will work with is virtually any kind of single ply membrane, the most common being TPO, PVC, or EPDM. Those are the 3 common single ply membranes. There are other membranes that are used in roofing, but these 3 dominate the single ply membrane sector. And then you have that concept of a quote unquote built up roof, often indicated by the acronym BUR, and that includes asphaltic built-up roofs, bituminous or modified bitumen roofs. There's coal tar pitch roofs. The basic premise is either you have a essentially a tar with a gravel covering. The purpose of the gravel is to reduce the deterioration of the tar or the asphaltic material underneath. So those rocks, in essence, stop the UV damage from occurring as quickly. It still occurs over the years, but it certainly slows it down. The other type of built-up roof uses a cap sheet that has a granulated surface, but underneath that you're usually going to have layers of tar and then a reinforcing fabric and some more tar or asphalt, another reinforcing fabric capped off with a modified bitumen cap sheet, which has those really nice granules. It's very similar to the kind of granulated surface you'd find on a traditional asphalt composition shingle. So those are the basic roof types, and again, our low slope mount, being a very generic product, will work with any of those roof types. Now, a traditional roof that's, or I shouldn't say traditional, but in recent years, the typical large low slope roof used in commercial structures would be some type of a corrugated metal deck. They usually would range between 18 to 22 gauge. The lower the number is, the thicker the gauge of steel. And what we would find in previous years is people would use a concept known as wood block mounting, where you cut a big hole through the roof, mount a wood block to the metal deck, and then you'd have a plate mount to that with a post, and then flashed. Time consuming, got to cut a large hole. Wood is not a particularly desirable material to introduce into a metal roof because, as one would imagine, any leaks that do occur, you've got the potential for having wood rot. Splitting the wood is certainly a potential when you're drilling holes through it, and heat-treated wood is advisable just to have structural capacity, and heat-treated wood won't deteriorate more as quickly if a leak does occur. The bigger problem with this style of approach is usually you have just a metal plate with a threaded stud sticking out of it that the post screws down onto, not very strong in shear force. There's also another concept called a ferrule mounting, which is more complex. It uses these tubes, these pipes that the fasteners go down through under the plate instead of a wood block. But as you can imagine, high part count, complex to install. The foam can compress when around the ferrules when you have a load applied, and the non-buttress plate mount is just not very strong. So in years past, we would see these single bolt post mounts used. does have a very limited lateral load capacity with only a single bolt, smaller diameter post. We do make the post diameter on the low slope mount 1.25 inch diameter. It is an aluminum post, and that very large diameter in our base allows us to handle more side load capacity. So deck mounting is just not practical as much with the single bolt base. Pitch pockets are actually an interesting concept, and they have been used for many, many years in the roofing industry, particularly with irregular shape penetrations like an I-beam or a piece of unistrut. Effectively, the concept is that you have a pocket that usually comes in two pieces like you see in the image there, and then you fill it with something called pitch. It used to be asphaltic or bituminous pitch. But the NRCA classifies this concept as the last alternative to consider only because of the routine maintenance and inspection. Time consuming, complex to install properly, can be leak prone due to freeze thaw cycles. And here's some common types of pitch pockets. Now the one in the upper left I like a lot. It's called a Chemlink E-curb, and it's filled not so much with a asphaltic or coal tar pitch. It's filled with a synthetic rubberized material which has a longer life. But if you're looking at the traditional pitch style versions pictured in the other images there, well, you can see that the pitch itself can sometimes degrade or will degrade over time with exposure to UV. And you just need to maintain that on a regular basis. Twice a year, you go up there, take a look at how they're doing and fill them with more pitch. So the concept of using an asphaltic or a coal tar pitch in these kinds of penetrations is probably not as common today as it was in years past. Of course, another approach that can be used is just using a form-fitting rain collar that keeps the moisture from landing on top of that pitch pocket. Deck level seal mounts we do see used. I don't know that I would classify them as common, but they certainly are a bad idea, and mainly because your seal is right there at the roof surface, at the water line, and whenever it rains, you've got moisture making contact with the vulnerable water intrusion area, and seals or sealant that are applied at the deck level just don't have a very long life. The reliable waterproofing of a seal at the water line like this or sealant at the water line is probably in the 5 to 10 years. So that's the reason why the roofing contractor, National Roofing Contractor Association advocates elevating your sealing area 4 to 8 inches above the roof surface, which can be done with a low slope mount that bolts directly to the deck. Very strong mount, fast to install overall. I'll show the procedure here in just a minute. Of course, again, we make it in 7, 9, 12 inches. Keep in mind, we can go up to 18 inches if you have the need for a higher post. You can use it with thick insulation up to 8-inch cone flashings. It offers a superior flashing seal. You only have to cut a 4-inch diameter hole through the membrane and the insulation, and that allows you to get an effective seal. So there's some various approaches that are used to secure the 4-inch diameter base to the roof deck. You can either use some nuts and bolts, particularly if you have access to the roof below. You'll certainly want to verify your attachment method with a structural engineer and make certain that the deck and the structure you're attaching to can support the necessary wind and seismic loads. So if you use you can use a thread forming 5/16 inch machine bolt going right into the deck. Or if you have access to the underside of the deck, you can use a good old-fashioned nut. I certainly like the robust connection capacity by using a nut. Now, as you can imagine, there are not many large low-slope roofs that have access to the underside, but some do. Gosh, you go into some warehouses, you look up, and there you see the underside of a corrugated metal deck. So that is certainly feasible. Of course, it would require somebody being able to access the underside of those bolts going through, but the structural capacity and reliability of a nut and a bolt is certainly desirable whenever possible. You can also use a zip toggle. Now, this is an interesting contraption. You can see from the image there that it's a kind of a U-shaped piece of metal that has a threaded welded component right in the center that your bolt will go through, and it has these clever plastic zip tie toggle doohickeys, and the way that it gets installed is as you see here. You have to drill a bit of an oversized hole. You then would orient the zip toggler so that the U-shaped piece of metal that's got the threaded nut in it will be aligned properly. When you're getting it aligned, you just break off or cut off the plastic zip ties, and it's ready to have the bolt installed through it to secure your attachment above the roof. Our low slope mount comes in boxes of 12 with all the hardware necessary to mount the L-foot to the top of the post. And then we do include 2 lag screws that allow you to mount into a wood rafter if you have wood rafters. The tools you'll need to mount to a typical metal deck include tape measure, marking pen, chalk line, drill with 1/4-inch bit, 4-inch hole saw, impact driver, 1/2-inch deep socket, and a roofing compatible flashing and pipe clamp. Of course, you want to have some sealant that would be used in conjunction. And in this installation method, we're going to show a typical corrugated steel deck. We're using a 4-inch core drill to cut a hole through the membrane down through the insulation to expose the deck. Now, as you can imagine, just looking at this image, you can see that that the position of your mount has to be over one of the peaks in the deck. You really don't want it going into the valley. Now that might make you scratch your head and say, gee, how do I know where those peaks are at? Now there's some different techniques. Probably the most common is exploratory drilling. You're going to patch over the holes that you use to figure out where it is if you drill wrong. But the good news is about corrugated steel deck is those corrugations are spaced at incredibly reliable, repeatable dimensions. So once you've found where your peaks are, you can now start to measure from peak to peak very accurately across the roof to mark out where the peak will be, 4 feet over or more. So you'll take your 4-inch diameter hole saw, cut through the membrane and the insulation, and get down to the peak of the corrugated roof. Here's a picture of that happening, and you'll then need to remove the remainder of the insulation. When we did this particular roof, I think it was 3-inch thick insulation, and we're just cutting it out there and taking out the chunks. Now I'd recommend that you save those chunks because they're valuable. Then we'll position our 4-inch diameter base so that it goes right down onto this metal deck. Mark our hole locations, which we'll drill out so that we now have, in this case, I think we're able to do it with 2 holes to get sufficient strength for the particular application. Then we used, these were done with thread forming screws. Those can be done. They're a real bear to install, but again, you can go right down into a thicker metal deck, and that can give sufficient structural attachment for many projects. You'll again want to validate your structural attachment with a qualified structural professional. Oftentimes a professional engineer will validate the fastener size, the fastener strength, the capacity with 2 bolts or 4 bolts into the deck, and determine if that's sufficient. In this case, using an impact gun to secure those bolts, and now the base is securely attached to the roof deck. Now, filling the void in with foam is desirable. I would certainly encourage just taking the foam that you've removed and sticking it right back in there. That will minimize the amount of what's called thermal bridging of the mount. Obviously, now we have a piece of metal that's exposed to the outside, and there will be a certain amount of heat transmission down through that metal post to the deck. But when you fill that insulation in, that helps prevent more thermal bridging from occurring. So that's the desirable approach. You can also use other types of foam. However, I will caution you that when you're doing work on a foam roof, there's compatibility problems with things like conventional spray foams and existing foam roofs. So you want to make certain that whichever foam you use to backfill those voids is compatible with the original foam so you don't get an adverse chemical reaction occurring. Positioning your flashing, which we will then seal down. Now in this example, we've got a TPO flashing that's being heat welded sealed to the TPO membrane. In some cases, you'll do a chemical seal, so it's glued down effectively. That's called chemical welding. That's the fancy term for gluing. But in this case, we're using a thermal heat weld where there is a heat gun that's being used by the roofer who's got a roller, and they will carefully start at the center of the flashing, welding that flashing down on the inside diameter near the cone, and slowly working outwards to make certain that you get a full adhesion across the surface. Again, when done properly, this can last easily the life of the membrane, and then finish off with some kind of pipe clamp and sealing washer. So that's the procedure. When you're done, you've got what you see right here, where you've got the flashing welded to the membrane and sealed with a pipe clamp, and usually our EPDM, heavy duty EPDM seal goes over the top of that to offer additional protection. Here's a picture of another large low slope roof with the tilt leg attachments. In this case, what we've got is a conventional tilt leg attached to the back row that will pitch up each row of modules off the roof surface. So that's a typical what you see before the PV array goes in. Now, I do want to talk about the residential sector because it seems like a good percentage of the folks here either do only residential or are doing residential and commercial. And as a result, they're going to run into what's known as rolled roofing. That's a very common roof type used residentially. And the reason it's common is because it's very affordable. It's a granulated surface that's rolled out in a big roll and then sealed down to the roof deck. So these usually are going to be a fully adhered. Now they are asphaltic based materials, so they by nature as they heat up, they will seal to what's ever underneath that, and then each seam will seal to the roll of membrane that's it's adjoining. You can see that there's a lap here of about 6 inches on this rolled roofing material. Realize that the roof in the background, being an asphalt shingle roof, is suitable, but only when the roof pitch gets to be about 312 or 412 pitch or greater. Whenever you've got less than a 312 pitch roof, a adhered membrane like rolled roofing would be suitable. Anything above 312 pitch, you would be eligible for using asphalt shingles. So this image is really nice because it shows both types of roofs. On any kind of built-up roof that would incorporate modified bitumen cap sheets like pictured in the lower right, the typical torch down flashing is a common approach where the metal flashing would be nailed to the deck, and then you would have a asphaltic material applied that then would get heated up with a big torch. Now, as one might imagine, this is a dicey proposition. The requirements from a safety perspective is they have not 1, but 2 fire extinguishers within 10 feet of wherever the torch is being operated, because you can burn a building down if you're not careful, because you're lighting a flammable material on fire to heat it up so that you can then stick that flashing down. Now, in this case, it's not on fire for very long. It's just being heated up, but you can see that it could catch on fire easily. And of course, you'll spread that hot tar around and then torch down. That's how the term comes along. The cap sheet to the hot asphalt underneath to get a really good adhesion. So this is a really reliable long-term seal. It's also very serviceable by nature of being an asphaltic material. Repairs are fairly straightforward. Hot asphalt goes on to any suspect part of the roof, but this would be the typical procedure. An alternative and less dangerous method of flashing is called a liquid polymeric flashing, like made by Elsan. Actually, the company that makes this is Soprema. That's S-O-P-R-E-M-A, Soprema. And this is a liquid polymeric flashing. The less expensive version shown on the right comes in that brown color. It's a 1-part, and all you do is put it on like paint. And the way that you do this is you're going to put it down. You're going to put on a coat of this brown liquid polymeric material. It looks by all accounts like a thick paint. And then you're going to press into that a white fleece material. Very soft fabric, actually. And then you're going to finish off with another layer of that thick brown paint. It takes about 24 hours to cure, but when you're done, you've got a really tough, leathery seal that has the capacity to last more than 20 years. So it's a approach that I really like. There is a faster setting, 1-hour rapid curing 2-part epoxy that's shown on the left there, and you can actually see very clearly that fleece material, that fabric fleece material that the white two-part epoxy is covering. The two are reportedly going to provide similar life. The main advantage of the two-part liquid epoxy, there's two advantages. Number one, it cures within 1 hour rather than 24 hours. That's a convenience. And number two, it can be colored to match different color membrane roofs. So that's kind of a nice thing if there is a aesthetic consideration to take into account. The other approach, which I think is probably my current favorite, is the E-Curb from Chemlink. Now, this is a two-part plastic form. You see pictured in the right-hand side. This is a nice cutaway. And the way that it works is you take this form, you put down a Chemlink M1 sealant on the underside to glue that form down to whatever roofing material, and it's compatible with just about all membrane and built-up roofs. There are some materials that it may not, I think, like if memory serves, I'm not sure if it works with a Hypalon single-ply membrane, not a very common one, but you'll want to make certain to check material compatibilities. And then what you do, you essentially take a Chemlink M1 sealant, very common sealant, high quality, very respected in the solar industry. You will put it on the underside of this 5-inch diameter form and glue it down to the membrane roof. Very popular on rolled roofs, by the way. And then what you will do is after your Q-base is mounted to the roof, you're going to pour the sealant into that cavity, that well. You can see here the sealant's been cut away. Actually, we put a little plastic divider there to make it look like a cutaway. Essentially, that sealant will fill that entire pocket, the E-Curb, and it never really hardens up. If you go to one that's been installed many years later and you press down on it, it still retains its elasticity, and that's part of the magic, is that this material does have such a resilience of elasticity over the years, so it doesn't crack. That's if it were to harden up, then it will crack more readily. But this material again has 20+ year life capacity, and Chemlink makes it in a 5-inch diameter, which works beautifully with our 4-inch diameter base of our low slope mount. Gives you a 1/2-inch sidewall of thickness of sealing. So this is a really robust. I always hesitate to use the term idiot proof, but when it comes to long-term reliable sealing with a mechanically attached mount, this is an absolute brilliant approach. Now, occasionally you might run into a concrete deck, common in certain structural types, in certain parts of the world. Concrete roof decks are very common in high wind areas like the Caribbean because they don't blow away very easily. So concrete attachments really have to be verified by a structural engineer. The 3 most common types of mechanical attachments include conventional concrete screws like the Tapcon shown in the upper right. Sometimes you'll see expanding anchors. I'm not a big fan because of the potential for cracking concrete. Adhesive anchors certainly are the best. You're going to drill out a hole, so you're not going to stress the concrete. You're going to fill it with a epoxy material. Here we're looking at, I think this might be the Hilti. There's a couple different manufacturers of these adhesive anchors where it's an epoxy, and as you essentially inject it, it mixes in the nozzle and squirts down in there, and then the metal anchor bolt will go into that epoxy. It will harden up, and then you've got a threaded stud sticking out of the concrete. Those are certainly the most expensive, but the best quality because they're not likely, I should say, to crack the concrete over time. And then you would seal the porous concrete with some type of a sealant. So that's the typical approach when you're dealing with concrete decks. Now, we do offer engineering reports for our low slope mount offered by a third-party test firm who's taken it to failure. When you look up our website, you'll notice things like that low slope mount bolted into a Douglas fir piece of lumber will have upwards of 3,900 pounds of capacity from pullout. And when you look at our shear capacity for the 7, 9, and 12-inch posts, you'll see we do post what the mode of failure is and what the whether it's post or the base breaking, but you'll see how much shear capacity in our 9-inch post below. You'll see that we can handle up to 763 pounds of side force on the 9-inch tall post. So that's really quite robust capacity, allowing you to span through thick insulation and still get a flashing of reasonable height on the roof. We also, for those mounting to wood rafters, publish the load capacity both in line with the rafter versus a perpendicular load. No surprise that your load parallel to the rafter is going to be higher capacity because you got 2 bolts going down into that rafter versus the perpendicular load, which is going to be a little weaker because you don't have as much structure there to resist it. But we do publish both those capacities at our website. And as stated earlier, whenever you really look at the strength of the base and the post, if you've got really strong fasteners into a thick metal roof deck, well, your capacity is pretty robust. The 7-inch can go upwards of 1,100 pounds of shear capacity. So that's pretty much the extent of it, folks. I will take any remaining questions. Our low slope mounts, of course, provide the capacity with their strength for longer spans on a roof, resulting in fewer penetrations, lower costs, and providing strong, secure, reliable waterproofing. So with that, I'll take a look at any questions that folks have. But before I do that, I just want to encourage everybody, do respect the roof, because it's an incredibly important part of the long-term cost of the PV system. Cost of ownership. We do have, of course, mounts for just about every roof type, from asphalt shingle to tile to shake, slate, metal shingle, low slope roofs. And our L mount is now readily available at distributors around the US. This is a economical solution for asphalt shingle mounts. Our classic conduit mount's been upgraded to the rounded corner flashing with alignment guide notches, as has been our popular E mount. Our universal accessory frame bracket, very popular for rail-free racking systems like our Quick Rack, where it will reliably bond the microinverter or maximizer mounting plate to the PV module. Very convenient. Our tile mounts are available. Our replacement tile mount gives you a unbroken concrete tile that you can use to service broken ones elsewhere on the roof, and it replaces it entirely and fits a broad range of commonly used tile on the market. Now available also for hooks in SW and flat shapes, and our conduit tile penetration flashing and conduit mount for tile are available, as are our Quick Rack rail-free system for asphalt shingle roofs. You can get our low slope mount or any product at our website by clicking the green free sample button. And don't forget to check out our new podcast titled Solar Roof Talk. It's easiest to find it by Googling that search term. You can also, if you're willing to do a few minutes of searching around, find it on our website. And our latest topic that we've addressed is a really hot topic of conversation, which is, fortunately, the fire code and building and residential code have been updated with the newer, revised, and reduced setbacks and pathways for fire clearance. So check out the podcast and you'll learn more. Our training vans now in California. If you're interested in having it stop by your place of business, give our sales folks a call and we can arrange to bring it by and do some training for your installers and your customers. My email address is shown on screen, jeff.spies, spelled like spies, at quickmountpv.com. You can phone our tech support line shown at the top of the screen. Our tech support is easily found at tech@quickmountpv.com, and Carlos Maldonado, who's our primary tech support rep, is very responsive, so you can usually get an answer within a matter of minutes, if not within the same day. Check out our frequently asked questions section of our website, where you'll find complete product information, engineering documentation, training downloads, a list of trade show and events and distributors, as well as get your free sample of any of the products that you're interested in. You can find us, our training, this is last year's training schedule, so it's subject to some date changes and locations, but we're anticipating being at all the events that we were at last year: COSIA, NABCEP, Oregon Solar Expo, Midwest Renewable Energy Fair, my favorite, in Wisconsin, Intersolar, and Solar Power International, this year to be held in Anaheim, California, not Las Vegas like this past year. So those are the big events of the year. Our website has all of our webinars. You can access the downloads or previously recorded webinars there, and check out our video tutorials, training downloads, and a list of hands-on training opportunities. If you participate in the full webinar, you will get 1 NABCEP credit sent to you via email. Check your spam filter. It takes 1 to 2 weeks for us to process those, and it will have links to download this presentation. Feel free to provide feedback at the end of the presentation. We appreciate very much everybody's questions, comments. We do pay very close attention to those to do our best to improve the material. With that said, I will check the questions, and there's a question here from Mike that says, do we have engineering data available? Indeed, we do, Mike. In fact, let me just kind of go back on our website. Bear with me while I page back to, so this is typical kind of information you'd find on our website. We'll publish your shear capacities. We have, for the low slope mount, we publish it both in the direction of a rafter if it's mounted to a rafter, as well as in the direction perpendicular to the rafter. And we include things like your pullout capacities, depending on if you're in Doug fir or other types of lumber. So just check our website and you can access that information. Hunter asks, sorry, any just ballasted systems without penetrations? Absolutely. We don't offer a ballasted racking system, Hunter. There's many on the market. Typically speaking, the ballasted racking systems would be used in conjunction for most jurisdictions with randomly spaced mechanical attachments to provide things like seismic load reinforcing, if you will. So as I stated earlier, it's a little bit nerve-wracking to presume that a ballasted racking system by itself will not move around. There are forces like wind, seismic, or just, again, thermal expansion contraction that can cause movement, where a mechanical anchor like the low slope mount would be a suitable companion to an existing ballasted racking system. So we don't make ballasted racking systems. I think that was the question. Andrew says, thank you, first time on, great job. Well, thank you, Andrew, for participating. I want to thank everybody for coming today. We're over the 1 hour mark, but again, I'll stick around if anybody has any other questions, but we hope that y'all can come see us at an upcoming event or join us for future training events. Scott asks, recommendation for large format interlocking concrete tile shingles, 16 by 16 inch. Scott, I'm not sure if I'm familiar with the particular concrete tile shingles that you might be mentioning. Maybe you're referencing what there is a class of cementatious concrete shingles. In Japan, they're very common. They're called colonial. Here they were a hardy shingle, if you will. They're relatively thin. They look and act very much like an asphalt shingle in terms of the way that they're installed. That may be what you're referencing. If so, Scott, those are tricky. They're not common here in the US. Again, they're very common over in Japan, and the approaches that I've used there leave me a bit concerned. That said, if that is the product you're referencing, it'd probably be good for us to have a follow-up conversation after today's presentation, so I can try to give you some guidance as to the best approach. Sean says, universal bracket quantity per case. Oh, that's a darn good question. Sean, off the top of my head, I'm not sure how many come in a box. But we typically have 12 packs of most of our roof attachments. I presume we do the same with these, but I have to admit I'm not entirely certain. Michael asks, what's your opinion of butyl rubber as a sealant? Butyl rubber is actually, when sandwiched between two pieces of metal, makes an excellent sealant. It's not a good sealant on a granulated surface. So if you're trying to apply it, for example, to a modified bitumen cap sheet that has a granulated surface, it's just not something that can seal efficiently around the uneven surface of granules. That said, when sandwiched between two pieces of metal, butyl can provide a really long, reliable waterproof seal, and that's the reason why butyl tends to be the sealant of choice whenever you've got a through-fastened metal panel, like a corrugated metal panel. Typically, when we see any kind of penetration there, the sealant that's used is a butyl because it will retain its elasticity over many years. Let's see here. Scott says, thanks, he'll reach out. And that's the only other comment or question we have, folks. I certainly appreciate, again, everybody's participation and attention throughout the webinar, and hope that we can be of, let me just scroll back to, all right, there's the end of our slide. So Michael says thank you. Again, I want to thank everybody who participated today and hope that you can join us. We have a webinar this afternoon called Successful Solar Business, which is participated in generally by new contractors, but even existing contractors sometimes listen in to get some tips and pointers as the industry is evolving. So feel free to sign up for that webinar that occurs in a little less than an hour and a half. And Mike says, thank you. Brent says, can you recommend a contact to discuss product development? Gee, Brent, I'm not entirely certain if I know what that might relate to, but if you want to give me a ring afterward, you can feel free to do so. Email me at jeff.spies@quickmountpv.com. Let me just go back to my email address so that you've got that handy, and I'm happy to try to address whatever question you might have on product development. There's my email address shown in the center of the slide. David says thank you. And again, thanks everybody. Have a wonderful day and a fantastic weekend coming up, and hope you'll join us again for a training event sometime down the road. Adios.